Hello and welcome to Kashmatics. In this video I'll show you how to calculate compound percentage changes. You're going to learn how to perform simple and compound interest calculations, how to calculate depreciation, which is just another word for how much value something loses, and also trial and improvement methods for compound percentage change. You're going to need to be comfortable with using a multiplier for percentage change, and if you aren't, please watch my video on that first. So grab yourself a pen and some paper and let's get started. To explain what compound interest is, we'll use this example. A person has £5,000 in a bank account and the bank pays compound interest at a rate of 2% per annum. Now per annum means every year. Assuming no further withdrawals nor deposits are made, so no more money is coming in and out of the account other than the 2% interest, calculate how much will be in the account in 4 years' time. Now with compound interest, you earn interest on whatever the balance is at that time, okay? And the balance keeps growing every time you earn interest. So after the first year, you'll have £5,000 multiplied by 1.02, okay? So whatever the answer to this is, that's what you'll have after the first year. Now when it comes to the end of the second year, you'd multiply whatever the answer to that is by 1.02, and again for the third year, and again for the fourth year. Now the 1.02, hopefully you'll recognize, is the multiplier for a 2% increase. Now instead of me doing this long calculation here, what I can use is powers to make the whole thing a bit simpler. So I could do 5,000 multiplied by 1.02 to the power 4. And if I do that, I get £5,412 and 16 pence. So that's my balance after 4 years. So let me just go through that again. The £5,000 is the initial investment. The 1.02 is a 2% increase. That's the multiplier for a 2% increase. And 4 is the period of the investment, in this case 4 years. Now let's use this example to understand what depreciation is. If something's depreciating, it means it's losing value. Okay, so let's look at this example. It's estimated that a particular model of car will lose 15% of its value every year. If the car is currently valued at £24,000, estimate its value 8 years from now. Now depreciation calculations are a little bit trickier because you need to understand what the multiplier is. So if something is losing 15% of its value, that means 85% of its value will be left at the end of each year. So my multiplier in this case is 0.85. So just like before, I've got the initial value over here, which is £24,000, multiplied by 0.85 to the power 8, because this is happening over a period of 8 years. So that's the initial value, there's your multiplier, and that's the period over which it's happening. And if I do that calculation, I get £6,539.77. Now obviously you wouldn't value a car with that degree of accuracy, but that's the actual value of this car based on this calculation. This formula here is a summary of what I've just told you in those last two examples. So the final value of any investment or anything which is appreciating or depreciating in value is the initial value multiplied by whatever the multiplier is for the percentage increase or decrease to the power n, where n is the period over which it happens. And here's two questions for you to try. Pause the video, make sure you are showing your working, because I'll be showing it in my final answer, and then you can play the video once you've tried it. So I'm about to reveal the answers in 3, 2, 1, and there you go. Okay, so nice simple calculation for these two. Okay, so the first one, 7,000 times 1.03, so that's a 3% increase to the power 6, which gives you £8,358.37. And for the TV, it's going to be 900 multiplied by 0.92, because if you're losing 8% of your value, it means 92% is left. And that'll be to the power 12, because it's losing it every month, and there's 12 months in a year. Now in this example, I'm going to talk about compound interest versus simple interest. Now there's a really important difference between the two. When it comes to compound interest, you earn it on the current balance at the time when the interest is paid. when you're talking about simple interest, is only paid on the initial investment. So let me explain how that works. So the first one, the compound, you should be okay with. The compound interest is going to be 4,000 multiplied by 1.03, because it's a 3% increase over a period of 5 years. So 1.03 to the power 5, which gives me £4,637 and 10 pence. Now, if you're wondering what that noise in the background is, one of my neighbours is setting off some fireworks, and there's not really much I can do about that. Well, I could record this at a different time, but I'm here now, so let's just crack on. Anyway, simple interest. Now, the way simple interest works is it's only earned on the initial investment. So the first thing I need to do is work out what 3% of £4,000 is. Okay, so remember, this is simple interest. Now, even though it's called simple interest, the calculation is actually longer. So I need to work out what 3% of £4,000 is, and I would do 0.03, not 1.03. I'm not increasing it by 3%. I just want to work out what 3% of £4,000 is. So 0.03 times by 4,000, which gives me £120. Okay, so this is what I earn per year. All right, so it's happening for 5 years. So I do 120 multiplied by 5, which is £600. Okay, and this is my total interest. And the final value will be my initial value of £4,000 plus the interest that I've earned, which is £600, which gives me a final value of £4,600. And this is less than what I've got over here, and that's what you'd expect, because in the first case, in the compound interest case, I was earning interest on whatever was in the account at the time the interest was being earned, okay? And that grew every year, so I was earning interest on more and more money. Whereas over here, I was only earning interest on the initial £4,000, which is why there's a difference between the two. So here's a question for you to try. A person wants to invest £8,000 for 5 years and has got a choice of two investments. Option A, simple interest at a rate of 2.5% per year, and option B, compound interest at a rate of 2.4% per year. Bear in mind, these two interest rates are different. The period of investment is the same, still 5 years for both, and the amount you're investing is still the same, which is £8,000. And what you've got to decide is the better choice of investment. So pause the video and give it a go, and I'll give you the answer shortly. So I'm about to reveal the answer in 3, 2, 1, and there it is. Okay, so option B is the better choice. You earn slightly more interest and it's a better investment. Now, sometimes the interest rate will change during the course of the investment, and we've got an example here in which that happens. A bank has a special offer and will pay 3% compound interest for the first 2 years of an investment, and then 2.5% compound interest for the remainder of the term. If £4,000 is invested for 7 years, how much will it be worth at the end of this period? And it's not as difficult as you might think. You've got the initial investment, which is £4,000, and you multiply that by 1.03 to the power 2 for the first 2 years. Okay, so that's the first 2 years covered. And then for the remainder 5 years, because remember it's a 7-year investment, we're earning 2.5%, so the multiplier is 1.025, and that'll be to the power 5. Okay, so you got initial investment, £4,000, 2 years worth of interest at 3%, and 5 years worth of interest at 2.5%. And if you were to do that calculation, you get £4,801 and 24 pence. So here's one for you to try. Pause the video and give it a go. And I'm going to reveal the answer in 3, 2, 1, and there it is. Okay, so you've got £5,000 initial investment. You've got 1.02 for your 2% increase. That happens over 3 years. And then you've got 1.015, that's your 1.5% increase for the remainder 6 years. And the final answer is £5,801 and 85 pence. And finally, trial and improvement. Now this can be used to work out how long it'll take for an investment or something to reach a certain value. So for example, an asset worth £1,000 increases in value by 4.5% per year. How long will it take to double in value? Now we are assuming this is a compound or repeated percentage change, and I'll show you exactly how it's done. So trial and improvement means just that. You try a value, see how you get on with it, and then improve on it to get closer to the answer you're looking for. And the first thing I do is draw myself a table. And with this question here, I need to work out what the multiplier is. So this is a 4.5% increase, because it's an asset that's increasing. So the multiplier is going to be 1.045. And in the columns over here, this is the period of investment, this is the calculation of the answer, and then a comment so I can keep track of where I am. So I'm going to try 10 years first. Okay, and for that I would do 1000 multiplied by 1.045 to the power 10, and I get £1,553. And that's too small. Okay, so I'm going to put too small in the comment box. Now I'm going to try 20 next, so that'd be 1000 multiplied by 1.045 to the power 20, and that gives me £2,411, and that is too big. So now I need to pick my next value. It's going to be between 10 and 20, and because these two numbers are approximately equal distance away from the answer I'm looking for, I'm trying to get to 2000. Okay, they're about 400 off. I'm going to try 15 next. For 15, I get 1000 multiplied by 1.045 to the power 15, and that gives me £1,935. Okay, and that is ever so slightly too small, so I'm almost there, but I need to be confident that 16 isn't going to be under as well. So let's just try 16. So that would be 1000 multiplied by 1.045 to the power 16, and that tips me just over. Okay, that's £2,022, and that is slightly over the amount I'm looking for. Okay, but what that tells me is that the answer is between 15 and 16. 15 is not enough, and 16 gets me slightly over. Well, this asset will take at least 16 years to increase in value, so it's double the initial value. So the answer is 16 years. And here's a question for you to try. Now remember, this one is depreciating in value. Okay, so think about what number you're aiming for. Set out your table in the same way, and I'll reveal the answer shortly. So I'm going to reveal the answer in 3, 2, 1, and there's my answer. Now yours might look different to mine in the sense of the working. 0.94 is still your multiplier. The numbers you might have chosen for the period will be different to mine, but the way you narrow it down is exactly the same. So as you can see from mine, 8 years isn't quite enough. Okay, remember I'm aiming for £9,000, and that's 10,000 something. Okay, 10 years wasn't enough either. Okay, but 12 years was too much. So then I tested 11 years to see if that was too little or too much, and that one wasn't quite enough, or the number was bigger. So I knew it was somewhere between 11 years and 12 years. So after 11 years, it hasn't quite got to halfway, but by 12 years it has. So it will take 12 years for it to lose half its value. And that's compound and repeated percentage change done. Thank you for watching and listening, and I'll see you next time. Goodbye for now.